ಸುಸ್ವಾಗತ. ನಾನು ನಿಮ್ಮ ಪ್ರೀತಿಯ ಮಾಸ್ಟರ್ ಟೀಚರ್ ಸುಹಾಸ್. ಹೇಗಿದ್ದೀರಾ? ಎಲ್ಲ ಚೆನ್ನಾಗಿದ್ದೀರಾ? ಎಲ್ಲರೂ ಚೆನ್ನಾಗಿದ್ದೀರಿ ಅಂತ ಭಾವಿಸ್ತಾ ಸ್ಟೂಡೆಂಟ್ಸ್, ವೆಲ್ಕಮ್ ಬ್ಯಾಕ್ ಟು ದೀಕ್ಷಾ ವೆದಾಂತು ಕನ್ನಡ ಚಾನಲ್. Today we going to discuss entire class 11 structure of atom unit. ಏನು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ ಇವತ್ತು? ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಆಟಮ್ ಯೂನಿಟ್ ನ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಎವ್ರಿ NCERT ಲೈನ್ ಬೈ ಲೈನ್ ಡಿಕೋಡ್ ಮಾಡೋಣ. ಮತ್ತೆ PYQs ಎಂಟೈರ್ NEET from the year 2017 to 2020 ತನಕ NEET PYQs ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. Okay my dear students, before starting the class, let me know in chat section everybody. The voice is clearly audible and the PPT is clearly visible. If it's visible and audible, then let me know in chat section. Everybody fast. PPT is clearly visible and your Suhas's voice is clearly audible. Then let us know fast everybody. Yes, my dear students. Hello. Now, students. Sorry for that. Yes. Hello. Check, students. Hello. Yes, now is started. Students, sorry for that. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಿಮ್ಮೆಲ್ಲರಿಗೂ ದೀಕ್ಷಾ ವೇದಾಂತು ಕನ್ನಡ ಚಾನಲ್ಗೆ ಸ್ವಾಗತ ಸುಸ್ವಾಗತ. ನಾನು ನಿಮ್ಮ ಪ್ರೀತಿಯ ಮಾಸ್ಟರ್ ಟೀಚರ್ ಸುಹಾಸ್. ನಾವಿವತ್ತು ಏನ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಷನ್ ಮಾಡೋಣ? ಸ್ಟೂಡೆಂಟ್ಸ್, ಟುಡೇ ವಿ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ಎಂಟೈರ್ class 11 structure of atom unit. It's nothing but physical chemistry. Physical chemistry is nothing but we have problem also in this unit, and also every NCERT line by line with 5 years NEET PYQ. Students, before starting the class, please do not forget to like, share, subscribe the channel, and also let me know in chat section. Now I know in starting the voice is not visible, sorry, not audible. Now it's audible. Come on, let's check once again. Let's check. Students, if the voice is audible, then let me know in chat section. Everybody fast. Everybody. Your Suhas sir is waiting. Fast, please. Everyone. Okay, I hope it's clear. Students, today we discuss entire NCERT line by line of structure of atom and important questions. Before entering to that, the first one is discovery of subatomic particles. We know, right? We already discussed some important introduction about atom in class 9. First, who come to discover the atom, or who tell about atom? ಯಾರು ಹೇಳಿದವರು? Who tell about atom? Dalton, right? Dalton. He is the first scientist who tell about entire first atomic model, or he gives some idea about atom. What he give? Atom is a indistinguishable or indivisible particle. The first point is atom is a indivisible particle, and also one important point he told. Which one he told? Important point, my dear students. He told all atom is a electrically neutral. What he told? ಅದು ಏನಾಗಿರುತ್ತೆ? ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಥವಾ ಯಾವುದೇ ಇದ್ರೂ ಅದು ಎಲೆಕ್ಟ್ರಿಕಲಿ ನ್ಯೂಟ್ರಲ್ ಆಗಿರುತ್ತೆ ಅಂತ ಹೇಳ್ತಾನೆ. ರೈಟ್ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್? ಬಟ್ ದಿಸ್ Dalton's atomic theory is get failed. So many Indian philosophers, what Greek philosophers are come, they give some idea about atom, particles, ಎಲ್ಲದ್ರ ಬಗ್ಗೆ ಹೇಳ್ತಾನೆ. Paramanu, Maharshi Kannada, right my dear students? Paramanu, he told about Paramanu. What is Paramanu? He told every matter is made up of one little teeny particle, that he told that he give a name. What he give? Anu, not Anusha, not Anu. It is Anu. He give Anu. Okay, after what happened, every Anu mixed or every Anu joined. Ella Anu ಏನಾಗುತ್ತೆ? ಎಲ್ಲ ಜಾಯಿನ್ ಆಗಿ it forms Paramanu. ಏನಾಗಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ? It forms Paramanu. This is very important. Who give these two names? Maharshi Kannada, right my dear students? Maharshi Kannada give these two names. And also after Maharshi Kannada, by using these important points, that what Anu, Paramanu, Dalton changed that Anu name, and also some Greek scientists give Anu as a atom. What Dalton told, he gave some idea. First he told very important 6 to 7 postulates are there. In these postulates we mainly consider on these two. Atom is a electrically neutral molecule. Very important. Atom ಏನಾಗಿರುತ್ತೆ? electrically neutral ಅಂತ ಹೇಳ್ತಾರೆ. ಅದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. And indivisible. It is indivisible. ನಾವು ಅದನ್ನ ಡಿವಿಸಿಬಲ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. Atom is a very teeny particle ಅಂತ ಹೇಳ್ತಾನೆ. ಬಟ್ ಏನಾಗುತ್ತೆ? by due to some activity or by using some experiment, this rule or this statement get failed. Then discovery of subatomic particles is happened. First, who is the father of electron? My dear students, let me know in chat section, everybody. The father of electron is J.J. Thomson. This fellow is there now, this scientist, he discovered the electron, presence of electron in an atom. How he discovered? Simply, students, here one magic is there. Take one rod or take one glass stick and simply wash that or simply take that one, simply clean that. After that, take near any particle. What happened? Otherwise, take one comb your head fastly, and take that comb near to the paper strips. What happened? The paper strips get attracted. It's nothing but whenever we do some experiment or whenever we apply some force, what happened? In atom also, some electrically charged or negatively charged particle is there. This is given by J.J. Thomson experiment. Which experiment, my dear students? Which experiment? By using ಯಾವ experiment? By using discharge tube experiment. By using discharge tube experiment, he confirmed that the presence of electron. How he confirmed? He take discharge tube. Discharge tube is nothing but one electrically tube, right? Not one electrically glass tube. It is an one glass tube. In end of that glass tube, it has high pressure. Then he pass electricity. Whenever he pass electricity, and in discharge tube, any one gas is there. Any gas. He placed some gas. What happened? After passing electricity, the new fluorescent glow is coming. New fluorescent glow ek barate due to bombard of some particles. The rays, he called those rays as which rays? Anode rays. It is passed from negative end of the electrode or negative side of the battery to positive end cathode. Negative in the cathode kade, sorry, anode in negative in the positive kade, anode kade pass ಆಗ್ತಿರುತ್ತೆ. Anode is nothing but positive charge electrode. Cathode is nothing but negative charge electrode. It passes from this end to this end, right, my dear students? Whenever this thing is happened on that ray, the negatively charged particle is there. Those negatively charged particle he called electron. What is the symbol of electron? E minus, right, my dear students? The symbol of electron is E minus. And also, what is the charge? -1. And what is the mass, relative mass? We neglect the relative mass of electron, right, my dear students? This is about discovery of electron. This is a experiment setup. This is an experiment setup. This is a cathode ray discharge tube, right? Oh, not anode ray. He called those ray as cathode ray, right? Oh my God, sorry for the students. He told that ray as cathode ray. Yes, sorry for that. He told not anode ray, cathode ray. Cathode is nothing but negatively charged particle ray. It consists negatively charged particle. Sorry for that, my dear students. Please forgive me. Okay. What happened? Vacuum pump. Why? Vacuum pump is there to give a gas or anything high voltage. Here high pressure is there. Fluorescent coating is there. What happened? Bombarding is happened and something is happened, right? From using this, he give this results. First ever point is the cathode rays start from cathode and move towards anode. Yes. Then these rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials. It can't visible. We can't visible those rays, but by using some experiment, by using some its behavior, what happened? Whenever it moving now, it bombard with other molecule. It bombard with the wall of a discharge tube, and it flow and it shows some fluorescent glow. By using that, we can easily discuss or we can easily absorb those rays. And in the absence of electrical or magnetic field, these rays travel in straight lines. Oh my God! If we not pass this ray towards any magnetic field in absence, here ನಾವು ಯಾವುದೇ ರೀತಿಯ magnetic field ಅಥವಾ electric field ಇಲ್ಲ ಅಂದ್ರೆ, in the absence of magnetic field and electric field, what happened, my dear students? In the absence, this rays clearly passing in straight line. What happened? It passes in straight line. Okay, my dear students, I hope it's clear. Then after that, in the presence of electric or magnetic field, the behavior of cathode rays are similar to the expected from negatively charged particles. If any field is there, any magnetic field or an electric field, how it behave? It behave very simply. It behaves as electrically negative charged particles is there na. Electrical negatively charged particle, what it behaves? Similarly, it behaves like this. That's why Electron is confirmed by using these results. And after the charge to mass ratio of electron. Who is this J.J. Thomson? He is a physicist. Physicist is nothing but physics scientist. It's nothing but, that's why this unit is called physical chemistry. This entire unit is related to physical chemistry. My dear students, artha aita? 1897, in 1897, British physicist J.J. Thomson measured the ratio of electric charge. E by M ratio. E by M ratio. Ratio of electric charge to its mass. Okay. What he gave, these three lines, these three important points is there. The magnitude of the negative charge on the particle greater the magnitude of the charge of the particle is greater is the interaction with the electric or magnetic field, and thus greater is the deflection. I repeat once. The magnitude of the negative charged particle greater the magnitude of the charge of the particle greater is the interaction with the electric or magnetic field. If we have greater magnitude, electric magnitude of charge is there na, magnitude of charge is greater than the deflection or the action or the behavior is there na, the deflection, it is greater the interaction with electric field and magnetic field is there na. Whenever we pass, it deflect towards the same canal rays deflect towards the positive end of the plate. Why? Because it is negatively charged, right, my dear students? That's why it deflects towards positive side of a plate. That's why this thing is told. Then the mass of the particle, lighter the particle, greater the deflection. If mass of the particle is lighter, mass of the particle is there na, canal ray particle, it is lighter, then the deflection is greater. It is inversely proportional. Inversely andre ಏನು, ಅದೇನಾದ್ರೂ ಕಡಿಮೆ ಇದ್ರೆ ಅದರದ್ದು ಡಿಫ್ಲೆಕ್ಷನ್ ಇದೆಯಲ್ಲ, ಡಿಫ್ಲೆಕ್ಷನ್ ರೇಟ್ is greater. Then after that, the strength of the electric or magnetic field, the deflection of electron from its original path increases. If we increase the, sorry for the students, if we increase the, if we increase the electric or magnetic field, the fields are there na, extra field strength. If we increase those field, what happened? The deflection also increases. Okay. By using this, he gives some E by ME ratio. This value is important. Either these are all not important. Only concentrate on this value. E by ME value, it's given by this. This formula or this value is very important in numericals. In numericals, these values are very, very important. In numerical, these values are very important. Okay, my dear students. After that, charge of an electron. Charge of the electron. Who give? By using R.A. Millikan, who is the scientist, he is also physicist. By using a oil drop experiment, he found the charge of the electron minus 1.6 into 10 power minus 19 coulomb. By using this, the mass of the electron become like this. Here, look, 10 power minus 31 kg. Minus 31 kg. It is too small. That's why we always neglect the mass of the what? Electron. This is E by ME value is important. Charge is important. Charge of an electron is always given by minus 1.6 into 10 power minus 19 coulomb. These two are very, very important. This about entire electron. Nan simple clarify martini nodi. Here we need to focus on these important points about electrons. Which of those? Concentrate here, my dear students. Solpa concentrate ಮಾಡಿ ಇಲ್ಲಿ. What is the charge of an electron? Charge of an electron is given by, this is a symbol, charge. Okay, symbol. This one is symbol. What about charge of an electron? Charge of an electron is given by oil drop experiment of R.A. Millikan experiment is given by minus 1.6 into 10 power minus 19 coulomb. This one is important. Then after that, what is the mass? Always we reject that mass. Then E by ME value. E by ME value. What is the E by ME value? Where is that? Yes, 1.75880. 1.75880 into 10 power 11 coulomb, right? This thing, E by ME value and other values are very important, my dear students. Okay. Then after this, charge, everything is done. Who discovered electron? J.J. Thomson, sir. Most of the time they ask in your exam, Who discovered electron? J.J. Thomson. Who is the father of electron? J.J. Thomson. Okay. Symbol is E. Their charge is -1. Relative charge. Relative mass, we always neglect the mass of an electron. And the coulomb. What is the exact charge? Exact charge of the compound or the electron, this one, -1.6 into 10 power minus 19. E by mv value 1.75 into 10 power 25. Right? These three are very important regarding about what? Regarding about electron. Okay, my dear students, electron is done. This is an experiment. What happened? If you pass a ray, then in the presence of magnetic field, it always deflects towards this. If in the object, it get this one. Here fluorescent screen, magnet, something is happened. Deflect ಆಗುತ್ತೆ ಅಂತ ತೋರಿಸ್ತಿದ್ದಾರೆ. Very simple. Next, move on to the discovery of proton and neutrons. Electron done, sir. What about proton? Students, proton is exactly opposite to the electron. Correct, my dear students? Protons are exactly opposite. It is exactly opposite towards neutron. Proton versus neutron army. Oh, not neutron. Neutron is waste. It is like proton. It is like brother of proton only. Proton versus electron. Always this fight is there. Proton versus electron fight is there. What is the difference? This electron is discovered by J.J. Thomson. This one, E.G. Goldstein, right? Who will discover this one? E.G. Goldstein by using canal rays. E.G. Goldstein, right? E.G. Goldstein. Let's discover this fellow. This fellow is discovered proton. This fellow is discovered electron. By using this experiment only, students, he never, okay, I explain once, okay, concentrate here. What he do? Very simple. He copy the same one, but he had one extra term. He had mercury. Okay, he take mercury wall in the fluorescent screen. Fluorescent screen is nothing but glass tube is there now. In that glass tube, discharge tube, he had some mercury. Very simple. By using this, he discovered this one. What happened after passing electricity? Some rays are passing from positive end to negative end. It moving from positive end to negative ends. It have positive charge. By using this, he discovered the proton. We already learned this entire concept. E.g. Goldsmith is always comes in metals and non-metals, that royal water concept, right? E.g. Goldstein concept, we already learned in class 9. It's not important. Here the important points are this one, canal rays. It's having, unlike cathode rays, mass of positively charged. What is the mass? Mass is nothing but +1. This relative mass is this one, and charge become 1 plus 6 into 10 power minus 19 coulomb. For electron negative, for this one proton 0 is there. This is entire property of fundamental properties. Okay, fundamental particles. If you know this one, if you know this table, you can easily score. You can easily solve entire problems. Okay, my dear students, entire problem ನೀವು ಮಾಡಬಹುದು. ಇಲ್ಲಿ ನೋಡಿ, what is the symbol of electron? E. Who discovered this one? Who discovered electron? J.J. Thomson. This thing, proton ಯಾರು ಡಿಸ್ಕವರ್ ಮಾಡಿದ್ದು? E. Goldstein. And neutron, this is homework for you guys. Who discovered neutron? Let me know in chat section or comment section. Okay, my dear students. After that, proton. What is the absolute charge? Absolute charge is -1.6 into 10 power minus 19 plus, and relative charge is -1 or +1. For this, there is no charges there. Neutral. It is a neutral molecule. Okay. Then after that, electron done. Then mass. What is the mass of electron? This one. We always neglect this value. Then mass of a proton. Both are approximately same. Both mass of a proton and mass of a neutron are approximately same. These are the relative mass. That's why we always neglect this relative mass. Sorry, relative, not a mass, is a mass. Okay, approx mass is this one, 0, 1, 1. Okay, if 5 proton plus 5 neutron is there, then its total atomic mass becomes 10 atomic unit. U is nothing but atomic unit, right? Then we have few important models. Thomson model. Next, move on to the Thomson model. Wait 1 second. Rutherford, yes. Then next, move on to the atomic models of structures. So many scientists come. Mainly the first scientist who give idea about atom is Dalton. But regarding about structure, J.J. Thomson is the first scientist who gives some idea. He come first and propose an atomic model. This model, it called as a plum pudding model or watermelon model, raisin pudding or plum pudding. What he compare the structure, he compare ಏನು ಮಾಡ್ದ ಅಂದ್ರೆ ಅವನು structure of atom, he compare entire structure to what? He compare entire structure. My dear students, ಏನ್ ಮಾಡ್ತಾನೆ ಅಂದ್ರೆ ಇವನು entire structure ನ ಒಂದು ಕೇಕ್ ಕ್ರಿಸ್ಮಸ್ ಕೇಕ್, he compares this entire structure of atom to Christmas cake. What he have? For example, take any cupcakes. What it have? Some dates is there, some dates and some yes, some dates is there which include the cake. He compared to that. And take watermelon is best example, students. Watermelon, what happened? It is look like a red. Wow, right? In summer, watermelon is best fruit. Right, my dear students? What happened in watermelon? Whenever you cut the watermelon to exact off position, the entire red part of the fruit, what happened? Some seeds are embedded it, right? Right, my dear students? See, layer nodi. Although yes, can be visited as pudding or watermelon of positive charge with plums or seeds embedded. ಏನಂತಾನೆ ಈ ಕೆಂಪುದು ಏನಿದೆ ಹಣ್ಣಿನ ಭಾಗನ ಅವನು he compare this entire to the atom. ಹೇಗ್ ಮಾಡ್ತಾನೆ? The entire ಹೇಗೆ ಅದು ಕೆಂಪು ಹಣ್ಣು spread ಆಗಿದೆ, entire how it spread, he compared this to proton is spread over all the atom and the electrons are embedded on it. This is a first point of plum pudding model. But students, this model get failed. But he give one important point here. He also told that electrically atoms are electrically neutral is nothing but how much number of proton is there, it is equal to number of electron. Number of proton ಏನಾಗುತ್ತೆ, number of electron equal ಆಗುತ್ತೆ. But what happened after this experiment? The new scientist come, Rutherford. He got Nobel Prize, one of the important scientists. He has one major contribution regarding about the structure of atom. What happened? He performed one new experiment called Rutherford alpha scattering experiment. He passed the alpha ray to the thin metal sheet. Which metal he use? Gold na use ಮಾಡ್ತಾನೆ. thin gold na ಅವನು ಯೂಸ್ ಮಾಡಿದಾಗ what happened? Due to the observation or due to the result of that experiment, this model get fails. In the later half of the 19th century, different kinds of rays were discovered beside those mentioned earlier. William Roentgen in 1895 showed that when electrons strike a material in cathode ray tube, produce ray which can cause fluorescence in the fluorescent tube. Since Roentgen, this thing is happened, X-rays coming, Henry Becquerel, radioactivity elements are discovered. But only concentrate on this now, okay? This is clear. Then move on to the Rutherford nuclear model of atom. Very simple, students. I already told now. What happened? I explain here. What is alpha particle? Before entering to the Rutherford nuclear model, first we need to have idea or we need to learn this alpha particle. Alpha particles are nothing but these are the positively charged particle. Which are alpha particle? These are the positively charged particle. My dear students, these are positively charged particle. And after that what? These are the positively charged particle and also positively charged particle. Then it has 4 atomic mass unit and +2 charge. It has 4 atomic mass unit and +2 charge. It's nothing but helium. What is the atomic number of helium, my dear students? It's 2. What is its atomic mass? 4. What is its structure? Nucleus is there. In this is valence cell, we have totally 2 electrons. Pass this, okay? In this electron or in this helium atom, just remove 2 electron. What we get? We get alpha particle. How we get alpha particle? It is also called as a He2 plus atom. Alpha particle is nothing but He2 plus atom. Whenever we remove 2 electrons is present in outermost valence cell of a helium atom, we get alpha particle. This is about entire alpha particle, entire basic. And its experiments, I already showed the schematic representation, but in its experiment, he choose gold. He choose gold, thin gold sheet. Why? In class 10th we already know gold is a most malleable metal. Why he choose gold? Because gold is a most malleable metal. It's nothing but what is the malleability? What is its property? If we beat the gold, now we are gold now. What is right? If we beat the gold, what happened? We can easily convert gold into thin sheet. Hena convert ಮಾಡ್ತೀವಿ gold into thin sheet. Due to that property, he choose gold because we can take very thin sheet. In this thin sheet, he choose gold metal na gold thin sheet. In this thin sheet, it has thicker, very thin. It has thicker only of 1,000 atom. We know we can't see in our eye, in our naked eye. We can see, students. No sir, we can't see the structure or the size of atom by our naked eye. We can see by ಎಲ್ಲಿ ನೋಡಬಹುದು ಅದನ್ನ by using macroscope, sorry, not macroscopic, microscope or other yes, by using microscope or other equipments, but we can't see that one. Okay, that's why he choose. It has thickness of 1,000 atoms size. Okay, this about entire operator setup and everything about alpha particle gold, everything is done. Then what he do? Yes, this is experiment. Source of alpha particle. He passed this alpha particle towards lead plate. Why he choose lead plate? Because one hole is there now. Due to that he choose. Then after that, then he passed through gold foil on. He cover the gold foil by fluorescent glow. ಯಾಕೆ ಇವನು ಈ ರೀತಿ ಮಾಡ್ತಾನೆ? Because to recognize the deflection. What happened? By using this, he gives some important results. First point, he give most of the alpha particle passed through the gold foil and deflected. Most of them. Look here. 1, 2, 3, 4, 5, 6. Here also it is also passed 7, 8, 9. More than 9 alpha particle it passed without undeflection. ಏನು ಆಗಲೇ ಪಾಸ್ ಆಗೋಯ್ತು. ಇದರಿಂದ ಏನ್ ಕನ್ಫರ್ಮ್ ಮಾಡ್ತಾನ ಅವನು? He confirmed that most of the atom are free, or most of the atom having free space. ಏನಾಗುತ್ತೆ? Most of the atoms are empty. Most of the space present in atom is empty. atom ಒಳಗೆ ಇರೋ most space ಅಥವಾ ಜಾಸ್ತಿ ಸ್ಪೇಸ್ empty ಆಗಿರುತ್ತೆ ಅಂತ ಕೇಳ್ತಾನೆ. And exactly small fraction of the alpha particles was deflected by small angles. Small angle ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಆಗಿದೆ. And exactly he deflected towards the same path. Okay, 180 degree. By using this, he gives some idea. He gives some important points here. Important regard. These are very important nuclear model points. Or this is not a postulate. But postulate is different. But he give one important idea. He give one important idea about nucleus. Who discovered nucleus, my dear students? This fellow Rutherford only discovered nucleus. ಏನಂತಾನೆ? What he exactly told? Whenever we pass alpha particles, whenever we bombard the alpha particle to the gold foil, what happened? Whenever we bombard the alpha particle to the gold foil, in atom, it have some free space, and also it has some positively charged space. ಏನಂತಾನೆ? It consists one positively charged space or positively charged sphere. This positively charged sphere are called nucleus. It called as a nucleus here. There, where is there? Enormous calculation by Rutherford. This thing is happened. 1 second, students. Yes, the positive charge and most of the mass of an atom was densely concentrated. The extremely small region, this very small portion of the atom was called nucleus. Who gave nucleus idea? This fellow only. What he told? Entire mass it concentrate on positively shaped or positively charged sphere, and entire charge of an atom, entire positively charged of an atom is due to this sphere. This sphere or this space is called nucleus. ಈ space ನಾವು nucleus ಅಂತ ಕರೀತಾನೆ. He called this space as a nucleus. Okay, my dear students. After second point, and electron is there now. Where electron is there? The electrons are revolving around the nucleus in certain orbit. ಏನಂತಾನೆ? He compare this structure, this electron revolving to our sun and earth, or our solar system. How the planets revolving around the sun. ಹೇಗೆ ನಮ್ಮ ಸೂರ್ಯನ ಸುತ್ತ ನಮ್ಮ ಭೂಮಿ ಅಥವಾ ಬೇರೆ ಗ್ರಹಗಳು ಸುತ್ತುತ್ತಲ್ಲ ಆ ರೀತಿ he compared this structure of atom towards that one. ಹೇಗೆ ಕಂಪೇರ್ ಮಾಡ್ತಾನೆ? The electron, how electrons are revolving around the nucleus, it's similarly to the solar system. He compared that one. Electrons and the nucleus are held together by electrostatic force of attraction. These two ಏನಾಗುತ್ತೆ, whenever we know, sir, we already know about some idea about electrostatic force. Whenever positive charge is there, negative, if negative positive both are there, then especially or then exactly or then obviously the attraction is there. Positive negative ಎಂದಿದ್ರೆ attraction ಇದ್ದೇ ಇರುತ್ತೆ ಅಂತ. Who told that one? This fellow. That's why electrons and neutrons, electron and proton, ಹೇಗೆ electron nucleus consists proton, positively charged is nothing but proton. Okay, on this side the neutron is still not discovered. Okay, my dear students, this thing about Rutherford model, but it is also failed. Why it's failed? One fellow is coming. Who is that fellow? Physicist Maxwell, not Glenn Maxwell. He is different Maxwell. What he told on the time, whenever the particle moves in circular path, what happened? It radiates some energy. ಏನಾಗುತ್ತೆ, ಅದೇನಾದ್ರೂ circular path ಅಲ್ಲಿ revolve ಆಗ್ತಿದೆ ಅಂದ್ರೆ, for example, run in circular orbit, what happened? After some time you lost your entire energy and you fell down. Similarly, the electrons or any particle revolving in a circular path which radiates energy, ಏನ್ ಮಾಡುತ್ತೆ, ಅದು ಎನರ್ಜಿನ ರೇಡಿಯೇಟ್ ಮಾಡುತ್ತೆ, which radiates its energy and it fall on the particle or it fall on the atom or it fall on the nucleus. That's why this entire Rutherford experiment get failed. But he gave one important idea. J.J. Thomson gave electrically neutral, important point. Electric atom is electrically neutral. It is very important. From using this fellow, he gave one idea. He gave an entire idea about nucleus. After that, we have few important terminologies. Okay, terminologies here. Okay, terminologies is there. This terminologies is very important. Atomic number and mass number is there. What is atomic number, my dear students? Atomic number is what is atomic number? It is denoted by symbol A. Atomic number is nothing but total number of proton present in an atom is called atomic number. What is atomic number? How much atom or how much proton is present in an atom is called atomic number. Here we need to tell, or here we tell the total number of proton, right, my dear students? Then after that, mass. What is mass? We already know. It is a sum of total number of proton plus total number of neutron. Almost this mass is same only, right? Proton or neutron. What is the approx mass? Every time mass is coming, approx mass, one atomic unit for neutron also. This thing is happening. Then isobars and isotopes. Isobar is referred to the element, the different element have same Z value. It is denoted by not MZ. No. Sorry. This denoted by Z, this denoted by A. Right, my dear students? Sorry for that. This denoted by Z to A. Correct? It has same atomic mass but different atomic number. What isobars? In the case of isotopes, it has same atomic number, different atomic mass. For example, hydrogen isotopes 1H1, 1H2, 1H3, and also chlorine isotopes Cl1735, Cl1737. These are important, right? It's clear. I hope it's clear. Yes, my dear students, this about isotopes, isobars, atomic number and mass number. These are few important terminologies. It is very important for your exams and your board exams. Next, more the drawbacks. What is the drawbacks? I already told the structure of atom, but here we have next atomic model. Then move on to the next atomic model. Which is the next atomic model? Bohr atomic model, my dear students. After Bohr, who is come? Wave nature is there, and we have, where is the PYQs? Yes, PYQs are present here. Okay, Bohr atomic model, students. Yes, any doubt is there still regarding about any atomic models or anything? Any doubt is there? Then let us know fast, everybody. ಬೇಗ ಹೇಳಿ, ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಫಾಸ್ಟ್ ಸ್ಟೂಡೆಂಟ್ಸ್. Any doubts, my dear students? Fast. Let us know. Let us know in chat section, everybody. One second, students. Yes, students, this about Rutherford. Remaining units we can discuss in next hour, our next part. Okay.